So, we will continue the discussion on fuel injection systems, and in this particular lecture we will see the nozzles and the type of fuel injector systems which we had discussed in the last lecture. So, let us come to see how the nozzles operate, how the nozzles are constructed, and what are the types of systems of the fuel injection pumps which are commonly used in automobile industry and also in, let us say, standard standalone engines. Okay. So, let us have a look at the PPT here. So, the type of individual pump and nozzle systems, so this photograph here, it shows you how a typical individual pump and a nozzle system works. Okay. So, the first thing which you see here is a camshaft. You can see the camshaft here. There is a fuel supply pump, there is a small pump through the filter, there is a primary pump which supplies pressurized fuel to the fuel pump, and later on the fuel pump's work is to give high pressure let us say delivery to the fuel injector nozzle. Okay. So, the first thing is that the camshaft operates the fuel pump. So, you can see the camshaft here, and this camshaft rotates, and as you can see, when it rotates, it pushes this plunger, and this plunger has the helix, you remember, which we had discussed in the last class. So, there is a helix pump here, and there is a control rod also. This control rod can move the rack and pinion, this rack and pinion can move, and it can turn this particular helix pump, which we have discussed in the last class, and there is a fuel delivery line from here. So, now this is an individual pump, one pump, which is the cut section is shown, and of course, the camshaft may have several cams, and there may be several pumps depending on the number of cylinders, for example. So, this is like a unitary assembly in which one assembly has several small pumps which are connected to the camshaft here for operation. So, the camshaft will rotate, there is a roller tappet here through which and then of course, there is an adjusting screw so that you can adjust the pretension here, and there is a retaining spring here which actually pulls the plunger back. So, the camshaft operates the fuel pump, the governor controls the control rack. As we have discussed in the last class, the amount of fuel delivery which is required by this pump or which is required from this particular pump will be controlled by the control rod, and it will turn this helix in such a way that metered amount of fuel goes to the output of the pump. The plunger pressurizes the fuel, the individual pump plungers are there for each cylinder. So, every cylinder which some of them you cannot see here, but there is a pump which is adjoining this pump, and there is a cam which is adjoining this cam, and so there, if there are 6 cylinders, there will be 6 cams, and all the 6 cams will be of course aligned at different locations, because every pump will deliver exactly at the time when that particular cylinder is supposed to fire. So, at that time only the fuel will be delivered to that particular pump. And then as you will recall from my last lecture also, there is a metal to metal sealing between plunger and the barrel. This particular plunger, with the helix plunger which we have seen, and the barrel outside, they will have a metal to metal sealing. That means the finishing is done in such a manner that even when it operates at such high pressures like 50 to 70 bars, for example, this particular fuel which is pressed by the plunger is not leaking out. Okay. So, this is the patented technology, and one has to appreciate that a very high level of tolerance and circularity is needed, and surface finish is needed, so that the plunger and the pump let us say body, there is no possibility of any liquid fuel to bypass and leak out from this fuel assembly. Okay. So, this is a construction of an inline plunger type fuel injection pump. Why we call it inline? Because these fuel pumps are all aligned in one line, and if there are 6 cylinders, there will be 6 such fuel pumps which will be side by side, and they will be supplied by one common fuel pump, and then 6 cams will operate these individual fuel pumps. So, here this pump is now connected to the nozzle, and as we have seen in our first lecture, that the work of the nozzle is that it has to create a spray. So, as you can see the close let us say view of this particular nozzle. Now, this nozzle also has there is a valve here, this is a pin valve, so to say, and the pressurized fuel will come and this will fill up this chamber, and when the pressure exceeds a particular value, this particular plunge, this nozzle pin will lift up. Okay. And how do you control the lifting pressure? The lifting pressure is controlled by a spring here, and on the left you see this is a mechanical type of a pump. On the right you see a solenoid operated pump. That means you can time the operation by a solenoid valve. So there is a retainer spring here, and this can go up and down because there is a magnetic field which is created by a solenoid, and this can go up and down, and the pressure, the fuel inlet will come and it will create a pressure in this chamber, and at the right time this particular valve will be opened up, and it can also be closed because there is a retainer spring here. So with a electromagnetic action here. So this is a solenoid type of a valve, which is modern engines have solenoid valves, but large engines, even today generator engines for example, they can have a mechanical pump only like that. So there is a lower assembly here, you can see where the nozzle is. So that is this zoomed view, and you can see this lower assembly is fitted to the upper assembly, and the nozzle assembly is at the bottom here, and naturally again there is a metal to metal contact between this, and this particular face has to be super finished so that there is no leakage of fuel. So naturally not all the fuel will go inside, and depending on the construction here there has to be a very clean action of this pin going up, and then there should not be any chattering, there should not be any vibration, there should be a very nice snap action by which this lifts up and then closes down. And of course the nozzle should be designed in such a way that there is no dripping, there is no, let us say, liquid remnant of the diesel should be here, because otherwise it will burn and it will form coke formation and it will block this particular nozzle. So this is a typical construction of a fuel injection nozzle. Now you can also have a rotary distributor type of a system. Okay, that means there is one pump, it pressurizes and meters the fuel, then this pump supplies it to a rotary distributor, and the distributor supplies to each cylinder when needed. This is typically a cost effective type of a mechanism. So here you can see, for example, so there is a fuel tank, there is a primary filter, and from there is a fuel supply pump. From this supply pump you have let us say one particular fuel, let us say the main pump is here. Okay. And then you can see injection nozzles. So there are 6 cylinders, for example, 1, 2, 3, 4, 5, 6, and there is a rotary valve here. Okay. So this particular rotary valve, this will the fuel injection pump assembly, that is the fuel injection pump assembly, this assembly will keep the fuel pressurized, and whichever cylinder wants to fire or wants the fuel at this particular let us say position, at that time this rotary valve, the distributor will actually supply to each of these let us say valves. So in this particular case there are no individual pumps for individual cylinders, but instead of that there is a rotary distribution valve, and you have high pressure fuel which is available by one fuel pump, but at every stroke one of the fuel nozzles will actually get the fuel supply. So and then of course the excess fuel which is remaining, depending on the application, how much fuel is needed, that is collected, and this goes back to the return line of the to the fuel tank. So you have a in tank filter, you have a primary filter, from there have the filtered fuel comes to the assembly of this particular one. There is only one pump, as I said, there are no multiple pumps, and this particular let us say pump, after the fuel crosses through the secondary filter, it comes to the pump, and then this rotary valve or the distributor will supply it to the individual nozzles. Now here is a common rail fuel injection system. I have also put some let us say photographs here. It is from the company Bosch, which is quite well known for fuel injection systems, and you can see here this is a schematic diagram of a common rail system. In a common rail system, essentially you have an engine control unit, you have these nozzles, for example, and the engine control unit is getting signals from various let us say locations. One of them is the speed, one of them is the power requirement, for example. There is also a pressure transducer which is connected to the ECU, and there is a high pressure line and a low pressure line. So essentially there is a high pressure pump, there is one common pump. This common pump will give it to a high pressure rail, and then all these lines are highly pressurized, they are kept pressurized and they are opened by solenoid by the engine control unit. Okay. So, you have control signals which are I mean through which the ECU determines that how much fuel is needed at what particular timing, and then since they are all solenoid operated, it is very easy to control the timing. The lift and the closure of the pump is easily controllable by relays which get signal from the engine control unit. So, again the system is similar. You have a fuel tank, you have a low pressure pump. From the low pressure pump you will pass through a primary or a secondary filter. From the filter there will be a high pressure pump. This high pressure pump will also be getting signal from the ECU, for example, and then it will inject, it will give high pressure line, and this high pressure let us say pump, you can even see a photograph here. You can see the common rail, this is the high pressure let us say manifold, and in this manifold you have high pressure fuel which is always available, and this is connected to a fuel nozzle, and this nozzle is connected, has a solenoid, and you can operate the solenoid with this particular let us say engine control unit. So, this is what is called as the common rail fuel injection system. Here is a cut section of a solenoid controlled nozzle. So, you can again see that there is a common rail, for example, this is there is an O-ring for this leakage not to occur. There is another last filter, because this filter is very important, because these nozzles have a very small diameter and therefore we do not tolerate any amount of let us say particulate matter which can come into this diesel. Sometimes sand particles can come, sometimes silica can come and things like that. So, they will come here, and then there is an electric coil, there is a magnet, and there is a retaining spring, there is again an O-ring for it to seal from the cylinder chamber, and as you can see on the side there is intake manifold for the air to come in, and there is a nozzle, it can have single hole or it can have multiple hole, for example, and here is another cut section of the same thing, and at the end it is connected to a needle valve. So, high pressure fuel inlet will come here, it will go through the screen, there is an electrical connection here which operates the coil, and there is a retaining spring, and you can open and close this particular valve with the engine control unit which operates this electric coil, and through the magnet the fuel can be injected. Again a photograph for you to see how exactly it is fitted. You can see the solenoid valve, you can also see the electrical connections, the cables which are running through, and here you can see how it is connected to the cylinder. Each of these let us say valves are connected. There is a common rail for pressurized pump, and here you can see how the ball type valve is operated with a solenoid. This 10 is a solenoid valve, 9 is the solenoid coil, and then of course the fuel will come, it will open, and there will be the spray tip is 15. So, there is a spray which will form inside the combustion chamber. So, with this we have seen some of the photographs, some of the let us say constructional details of fuel nozzles, also some of the systems like the common rail injection system, or a single unitary type of a pump, or inline pumps. So, several designs are available, and depending on what type of an application you are aiming at, what is the economics of that process, also the type of space which is available. Sometimes let us say in marine engines or small engines not enough space is available. So, there are several factors which have to be seen before you choose a particular type of a fuel injector system for a multi-cylinder engine, for example. So, we will continue this discussion and see how what are the spray characteristics and how these sprays are operated, etc., in the coming lecture.